Hi, this is our video for CVM 5 about position versus time graphs. These position versus time graphs are going to be graphs that we make a lot. And they're especially important because we can tell a lot about what is happening in a situation just from this graph. So let's see an example of what this graph looks like. We are graphing position on the vertical axis, and that'll be in units of like centimeters or meters. I'm going to show meters here. And I'm just going to write a T on this axis, which will be in units of seconds. One thing that we want to pay attention to is often we'll see that the position graph has two parts to it, a positive part and then a zero, and then the negative part. We'll want to pay attention to the positive position values and the negative position values. We can imagine something starting at an initial position, like this initial position right here. I'm going to write initial position. And let's say that it moves like this, like this, like this, like this, like this, like this, and then the graph changes. Even though this graph doesn't have any numbers, we can still tell a lot about what's happening in the situation. So I want to show you an example of what this would look like in the real life, in real life, with the help of Miss Smith, who has a red buggy in her hands, and she's going to start it moving from an initial position of 1 meters. Go ahead and start clock reading. 0 goes now. Notice the buggy moves and the buggy moves, and then it stops. It stops because Miss Smith stopped it. What I want to point out is like this buggy crossed the 0 line, or the 0 point, moving from 1 meter in this direction, this direction, this direction. Its motion didn't change when it crossed the zero point. It kept moving at a constant speed in this direction. It only stopped when it got over here. We can see that in our graph just by looking at where this graph changes. This is the point where the graph, where the buggy stops. So I'm going to label that here. I'm going to say the buggy stops at this point. Another thing that I want to specify is that the speed doesn't change. The speed doesn't change here. In fact, nothing at all about the buggy's motion changed as it crossed that 0 point. It just kept on moving. We can see that in the graph as a place where the position was 0 for just an instant. So let's look at what this looks like in a description. We can say the object, in this case it was a buggy, but it wouldn't have to be, starts at an initial position of, let's say for this example, it was positive 1 meter. So we can say positive 1 meter, and moves toward the x equals 0 point in the negative direction. That is, that buggy was moving towards the negative sign on the number line rather than moving towards the positive sign on the number line. If the buggy switched direction and it was moving this way, then even if it was in the negative position, we could say it's moving towards that positive side of the number line. So we can tell that by looking at this graph. We can see that this graph shows that the buggy is moving in the negative direction. Last thing I'm going to say, then stops moving at a negative position. We can tell that it stops moving because this graph gets flat. In general, if we want to read a graph, I'm going to write reading a graph with no numbers. This is specifically for a position graph. If the graph has a slope, that means that the object is moving. If the graph is flat, that means it's not moving. If the graph is more steep, that means it's moving fast. And if it's less steep, that means it's moving slowly. So you could write some more things down here if you wanted to write some stuff that's going to help you read these graphs that don't have numbers on them. But things like this, did the buggy speed up? Did the buggy stop moving? Is it moving fast? Is it moving slow? We can tell that by just looking at a graph, at a position graph, even if it doesn't have any numbers on it.